Okay. So what was the last topic we were discussing about under capacitance? Anyone? What was the topic?
So we have completed.
Types of capacitors, I hope so, right?
Yes, sir. Cylinder capacitor. Till that we completed, sir.
Okay, have you seen the series and parallel? What is the formula? We have seen it, I hope so, right?
Yes, sir.
Okay, so we'll continue from there. Then we'll have series and parallel, we'll do some problems, and today we'll try to complete it. Okay, so let's see. So last class we have discussed about the capacitance. There are four types of capacitors are there, and one minute. Yeah. So there are four types of capacitors are there. So one is your isolated spherical capacitor. So isolated spherical capacitor, it is completely totally different and totally away from the other capacitors. So C is equal to 4 pi epsilon naught R. This is your relation. And for the parallel plate capacitor, C is equal to epsilon naught A divided by D. Okay, it is your parallel plate capacitor. And after that, we have seen the concentric circles. So C is equal to, it is your spherical capacitor. C is equal to 4 pi epsilon naught A, and then there are two different radiuses are there. So the formula is, I'll give the formula 1 minute. So C is equal to 4 pi epsilon naught. It is AB by B minus A. So this is your spherical capacitor. And the fourth one, cylindrical capacitor. So the linear charge density, the relation will be there. C is equal to 2 pi epsilon naught L by long log of B by A. These are the four types of capacitors. Okay. Apart from these four types of capacitors, we have seen the series connection formulas. So for series connection, the relation is C equivalent. That is your 1 by C equivalent is equal to 1 by C1 plus 1 by C2 and so on. So it is for your series connection of capacitors. So this is your series connection of capacitors. And for the parallel connection, C equivalent is equal to C1 plus C2 and so on. So this is your parallel connection. Okay, right. So with respect to this series and parallel connection, we'll do some problems, and after that we'll see the dielectric constants. Okay. So assume I'll give a circuit. Okay. So try to solve it. If you know it, please do it, or else I'll do it. Okay. Question is, first question. Calculate the charge supplied by the battery. Calculate the charge supplied by the battery. Charge supplied by the battery. So let's see. So there are two capacitors are there. I'll give the capacitors also. There are two capacitors like this. This plus and minus. Why plus and minus? Now there are two parallel plates. One is your positive plate, one is your negative plate. So C1 is equal to 5 microfarad. So micro value on the 10 power minus 6. I'll give the value. Micro is nothing but your 10 power minus 6. Farad is your unit for capacitor. Okay. And there is one more capacitor. I'll take this one. It is a plus and as well as minus. It is plus and it is minus. So I'll take this one as C2. So C2 is equal to 6 microfarad. Okay. So for this, I'm connecting a battery. So this battery, it is a plus minus. For this battery, the voltage is 10 volts. And I'm connecting connection, right? So this is your circuit one. So there are two capacitors are there, C1 and C2. So I need to find the charge. So we know the relation Q is equal to CV. So what you have to do, you have to find the C equivalent first. After that, we need to find the charges. So if you know it, please do it now. Find the C equivalent. First identify whether it is series or parallel connection, please. Try to do it, ma. So there are two capacitors are there. So first identify whether these two capacitors are series or parallel. Are you people doing it? கொஞ்சம் ரெஸ்பாண்ட் பண்ணா நல்லா இருக்கும். So try to find the C current. Anyone? What is the C current for the circuit? Okay, I'll do it. Okay, just check it. See, so in this circuit, I have given you two capacitors. I have to check first of all whether it is a series connection or parallel connection. To check the series and connection, parallel connection, just try to identify with respect to your current directions. If the same current is flowing through the two capacitors, it is a series connection, same circuit, same current. Okay, so you already know this one. If you are discussing about the different currents, it is your parallel connection. Okay, so let's just see. So suppose here this is your battery, the current is flowing from the battery and it is returning back to the same point. Okay, now at the junction, so what are the point are there, what are the path is there, different path, dividing path, so we call it as your junction. At the junction, what will happen, the current is dividing here. Okay, I'll take this one as I1 and I'll take this one as I2. So here the current is flowing here for this capacitor C1 and here there is a current for the capacitor C2. So we see that these two capacitors are again adding at the B point, at the junction B. Okay, again these two are adding, and again the same current is flowing through. Okay, so remember when we are discussing about the circuit, okay, first try to identify whether it is a series or parallel. Okay, now here if you see that these two are of different currents, so we can say that these two are of series, these two are of parallel circuits. So I'll redraw the circuits. I'll redraw the circuit. This is your capacitor, this is your plus minus, it is your C1. So C1 is equal to 5 microfarad, and I'll take one more capacitor. This is your capacitor, this is your C2 plus minus, C2 is equal to 6 microfarad. 6 microfarad. So these two are connected to a voltage of 10 volts. Okay, plus and minus. Okay, now you can see that these two are parallel connection because there are two different charges out there. Okay, instead of current, we have to discuss about the charges only. So for parallel connection, what is the formula? C equivalent is equal to C1 plus C2. So for this one, C equivalent is equal to 2. So C1 is 5 microfarad plus C2 is 6 microfarad. Remember, if both are having same like microfarad and microfarad, so we can add it directly. It is 5 plus 6 is nothing but your 11 microfarad. If both are of different times, that means the prefixes are different. Then that moment we have to cross check it. Okay, so C equivalent is equal to your. So now what we need to find? We need to find the charge. So we know the relation Q is equal to C equivalent into V. So C is your 11 microfarad and voltage is your 10. So charges are, it is your 110 micro. The unit for charge is nothing but your Q. So this is your charges. Okay, please. யாரும் அது சந்தியா மியூட் பண்ணுங்க. Okay, so please take this one. Or others, please let me know. Right, okay, good. So let's see one more question. So question number 59, ma. Take the question, example 59. Example 59. Take the question, ma. Or I taken the question. See in this question, if you see that, so there are three capacitors are there, C1, C2 and C3. Okay, let's see the relations here. Let's see the question. Three capacitors C1, C2 and C3 are connected to a 6 volts battery as shown in figure. Okay, so now, so what we need to find, we need to find the charges on the three capacitors. We need to find the charges on the three capacitors. To find the charges on the three capacitors, first of all, we have to identify the equivalent capacitance. Okay, total capacitance, equivalent capacitance first now the identify. Let's see the relations. So for this circuit, so we have to identify which one is series and which one is parallel. So what I'll do, I'll allow some charges passing through it. Okay, when the charges are passing through it, okay, so at this point, what will happen? Again, the charges are dividing. I'll take this one as, okay, I'll take this one as Q1, I'll take this one as Q3, and I'll take this one as Q2. Now, if you see that all three are of different charges passing through it. So first of all, when they have given you the circuit, first of all, try to identify. So we have to come at the end portion, and then we have to solve it. You see that, so here there are two capacitors are there, C2 and C3. So these C2 and C3 are of different charges passing through it. When there are different charges, we have to identify this as your parallel connection. So first we have to solve it. Okay, so C2 and C3 are parallel. So C2 and C3 are parallel. So for parallel, what is the formula? C equivalent is equal to, it is C2 plus C3. So which is equal to, it is a 5 microfarad and plus 5 microfarad. So the total is nothing but your 10 microfarad. So this 10 microfarad is there. So I'll redraw the circuit like this. So there is a voltage, there is a capacitor. So this capacitor is C1. C1 is equal to 10 microfarad. And there is a capacitor. So we just got this capacitor, equivalent capacitor. So this equivalent capacitor value is nothing but your 10 microfarad. Okay, so it is your voltage plus or minus 6 volts. So like this, I have to redraw the circuit. So suppose you on the exams apart from your MCQs, you have to solve like this. Then only you'll get the marks. Okay, now you have to see that. So now on the equivalent circuit, find out. So if you see that these two are in series connection. So C1 and C equivalent both are in series connection. Series connection formed another 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Okay, so 1 by C1, so it is 1 by 10 plus 1 by 10, so it is nothing but your 2 by 10, so which is equal to 1 by 5. So you have to reverse it. So when you reverse it, C equivalent is equal to, so it is 1 by 5, that is your 5 microfarad. So 5 microfarad and சொல்றது இங்கே வந்து இருக்க terms prefixes எல்லாமே same ஆ இருக்கிறதுனால I can directly take 5 microfarad. So we know the capacitor is 5 microfarad. Now what we need to find, we need to find the charge. So formula another Q is equal to CV. Okay, this is your total capacitor. So I'll redraw the circuit again. Only one capacitor will be there. It is plus or minus. It is your 5 microfarad, and this is your voltage across it. So we need to find the charges first of all. So either voltage on the plus or minus 6 volts. Okay, like so Q is equal to CV. So Q is equal to C is your 5 micro into voltage is nothing but your 6 volts. So the value of charge is nothing but your 30 microcoulomb. This is your charge. And what are the charge we are finding here? This charge is nothing but your Q1. Here on the in the Q1 and the same charge the flow ahead. So now, so first of all, take this one. After that, we'll try to find Q2 and Q3. Take this one. Step by step, those who already know it, please do it. So we need to find the charges Q2 and Q3. All? Or please let me know. Make it fast. Others? Okay, right, good. So let's see. So we are going to find your charges. So what I'll do, now I will just mask monitor. So I'll redraw the circuit. So we know the charge Q is equal to CV charge எனக்கு தெரியும். So what is the value of charge? So charge is equal to Q is equal to 30 microcoulomb. So what we need to find? We need to find the balance two charges Q2 and Q3. We need to find it. So to find that, so இதுக்கு முன்னாடி வந்து redraw பண்ணிருக்கோம் circuit. I'll redraw it again. So C1 is equal to 10 microfarad and here C2 is equal to, that is your C equivalent is equal to your 10 microfarad. So this is the thing. Okay, let's just see. So this is your voltage. And remember when we are discussing about the series connection, இங்க வந்து voltage என்ன இருக்கும்? Voltage will be dividing. Remember voltage will be dividing, current will be same. That is your charges will be same charges flowing through these two capacitors. Ana voltage will be dividing. So the voltage is here because of the capacitors rendu same values irukadanaala equal divide agum. So the value for this capacitor will be that is your voltage will be 3 volts. Here 3 volts and here 3 volts. Equally divide agum. Okay. Now again these equivalent capacitors is nothing but your parallel connection. Again now the redraw pandren. So this is your capacitor, it is your C1 and again there is two capacitors which is your C2 here and this is your CT. It is solved another, we are getting 10 microfarad here. Okay, so I'm adding a voltage, right? So plus R minus 6 volts. So C1 there is a voltage of 3 volts here and here also there is a voltage of 3 volts. Okay, and capacitors on the C2 is equal to, it is your 5 microfarad and here also C3 is equal to your 5 microfarad. So what we are going to find? We are going to find the charges. So parallel connection, voltage same. Remember, for parallel connection, the voltage is same. So for C2 and C3, 3 volts will be there. Same 3 volts will be there. Okay. So now we are going to find the charges. So Q2 is equal to C2 into V, and Q3 is equal to C3 into V. So C2 is nothing but your 5 microfarad. 5 microfarad and voltage is nothing but your 3 volts. Okay, and C3 is nothing but again 5 microfarad and voltage is nothing but your 3 volts. So if you solve it, it will be around 15 microfarad and here also it is a 15 microfarad. So these are your charges one. If you add these two, you have to get the Q. So Q is nothing but your 30 microfarad. Values the same equal charges on the split item. So please take the, so Q2 is equal to your 15 microfarad and Q3 is nothing but your 15 microfarad. நான் ரொம்ப ஃபாஸ்ட்டாக மூவ் பண்ணிட்டு இருக்கேன், பட் இஃப் யூ ஹேவ் எனி டிஃபிகல்ட்டி ப்ளீஸ் லெட் மீ நோ. இது சீரிஸ் அண்ட் parallel கனெக்ஷன் ரொம்ப இம்பார்ட்டன்ட். ஸோ இதே கான்செப்ட்ஸ் திரும்பி உங்களுக்கு வந்து தேர்ட் சாப்டர்ல வரும், கரண்ட் எலக்ட்ரிசிட்டி. ஓகே, ஸோ ப்ளீஸ் டேக் திஸ் ஒன். Over. Others, is it over? Yeah, ma'am. Okay, good. So let's see. So please take this question 60. Take question 60. Have you taken the question? Okay, let's see that. So question என்னன்னு பார்க்கலாம். So find the equivalent capacitance of the combination of capacitors between the points A and B as shown in figure. Also calculate the total charge that flows in the circuit when a 100 volts battery is connected between the points A and B. So what we need to find? We need to find the total charge. So total charge which is passing through the circuit, okay, between the points of A and B. Let's see. So remember in the மாதிரி question வந்துச்சுன்னா, so remember A point is your starting point, B point is your ending point. Just remember that A point is your starting and B point is your ending. You can connect a battery between these two. You can connect a battery. So A is your positive terminal and B is your negative terminal. So in between these two only we are going to find your charges. But before that, so what I'm going to find, we are going to find the equivalent capacitance for this circuit. Okay, so first we'll try to find the equivalent capacitance. Let's see that. So when you say the A terminal is positive, the current is flowing from the A terminal. Let's just see that. So it is your charges passing through it. I'll take this one charge. At this point, remember it was splitting. Okay, so what you have to do, you have to identify which one is series and which one is parallel connection. That is the thing here. Okay, and again, I'll take this one as Q1 and I'll take this one as Q2. Again, these two are dividing here. I'll take this one as 3Q3 and I'll take this one as Q4. Individually on the find out panna sollala, we need to find the total charge. That's it. Okay. Now, so here we all identified the series and parallel connection. So let's see the equivalent capacitance here. So in this circuit, if you see that, so Q1 current is flowing through three capacitors. Q1 current is same charge is flowing through three capacitors. Same charge is flowing through three capacitors. So three capacitors are in series connection. Here these three capacitors are in series connection. Okay, so the formula for the series connection is 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, and you'll get a C equivalent for this relation for the three capacitors. Now, so when you come back to this one, 10 microfarad and 10 microfarad, these two are connected in parallel. These two connected in parallel. When these two are connected in parallel, so we know the formula C equivalent is equal to C1 plus C2. C equivalent is equal to C1 plus C2. So after finding these two for series and parallel, okay, I'll redraw the circuit. Now I'll redraw the circuit. After that, we'll solve the final circuit. Okay, so the circuit will be like this. So it will be, so A point, there is a capacitor. This capacitor is your 40 microfarad. Okay, so when you solve the series connection, the capacitor value will be like this. You are going to give me the C equivalent capacitance. So for series connection. Okay, and same thing. So what we need to find, you have to find the parallel connection. Adukku oru C equivalent varum. So you have to tell me that C equivalent value, and this is your B point. So the parallel connection is the series connection value. So after finding it, just give me the values. So and if you see that, so after finding it, I have to redraw the circuit like this, and after this, and I have to identify which one is series and which one is parallel again. Now if you see that these two are again parallel connections. These two values are again parallel connections. After finding the parallel connections, what we have to do, again I have to redraw the circuit. The circuit will be like this. So this is your A point and this is your B point and this is your 40 microfarad. After that, it is your series connection. Like this, you have to solve. Let's see. You can take the values. For C equivalent, so it is 1 by C1 plus 1 by C2 plus 1 by C3. So the values are like this. So the values are like this. So it is 1 by 60 plus 1 by 60 plus 1 by 60. So which is equal to your 3 by 60. So I'll reverse it because 1 by C equivalent is equal to 3 by 60. I'll reverse it. When you reverse it, it will be 60 by 3. Okay, so C equivalent will be 60 by 3. So 60 by 3 is nothing but your 20 microfarad. So C equivalent is equal to 20 microfarad. So this value, this three capacitors value is your 20 microfarad. Now let's see these two. So these two are in parallel connection. For parallel connection, formula is C equivalent is equal to C1 plus C2. So it is a C equivalent is equal to your C1 plus C2. So which is equal to C1 is equal to 10 microfarad and again C2 is nothing but your 10 microfarad. So it is equal to 20 microfarad. Okay, now I'm going to substitute these values here. It is 20 microfarad and it is again 20 microfarad. Now if you see that these two are in parallel connection, for parallel connection again it is nothing but your C1 plus C2. So it is a 20 microfarad and plus 20 microfarad, which is equal to your 40 microfarad. Okay, now I got the two capacitors here. After solving it, we will get 40 microfarad here for this capacitor, and already we have 40 microfarad. Okay, if you see that these two are in series connection, when you solve it, the C equivalent is equal to, that is your 1 by C equivalent is equal to 1 by 40 plus 1 by 40. So which is equal to your 2 by 40. So which is equal to 1 by 20. Okay, so C equivalent is equal to your 20 microfarad. So like this, you have to check it and you have to solve. So only your time item, so it won't take much time like this. Okay, so you have to do practice. So this is your C equivalent now. Please take it. Okay, now we got the C equivalent. What we need to find? We need to find our charges. Charges passing through this circuit. So here they have given the voltage is 100 volts. The voltage is 100 volts. V is equal to your 100 volts. And we know C equivalent is nothing but your 20 microfarad, which we got it from this point. So it is your total capacitance. Okay, now we are going to find the charge. Q is equal to CV, which is equal to 100 into 20 microfarad. So I'll take this relation as, you can write this as 2000 microcoulomb. Okay, 2000 microcoulomb, or I can write this relation as 2 millicoulomb. Milli is 10 power minus 3. This is your charge. Please take it. So you have to solve like this. Over. Others, is it over? Okay, right. So let's see one more. So next question on the it is important. Okay, for your need in the மாதிரி patterns questions வரும். Simple தான். Please take this question. Question number 66 mark. So sometimes we can expect this type of questions in your need papers. Okay, please take it. Example 66. Okay, so let's see the thing. So in this question, so four capacitors are connected as shown in figure 2.71. Calculate the equivalent capacitance between the points X and Y. So we need to find the equivalent capacitance. That's it. Okay. So first of all, we have to check whether this is in series connection or parallel connection. Okay. So for that, what I have to do, I have to allow some charges passing through it from the X point to the Y point. It is starting point, it is ending point. You have to consider it. Okay. So at the A point, what will happen? It was dividing, and again this point was dividing, and again the point it was adding here. Okay, again it was dividing. So there are different divisions are there. So we can say that all these three capacitors, that is your 2 microfarad, 3 microfarad, 5 microfarad, all the three are your parallel connections. Okay, so why parallel connections now? Because the currents are different here. Okay, so are of different currents here. Okay, now so but even though these are different, because of the connections between this A point to this point and between this point to the B point. Okay, so here it's just a connections only, there is no capacitors. Even though there are no capacitors, we have to consider for the current alone, not for the series connections or parallel connections for the capacitors. So for that, what I'll do, I'll redraw the circuit, avoiding these joints here. Okay, so because of the currents, so it is your parallel connection only. I'll redraw the circuit. So it will be like this. So there is your X point, and for this X point, from this X point, there are three capacitors are there. All three are connected in parallel. All three are connected in parallel like this because of different currents passing through it. Okay, so it is your 2 microfarad, it is your 3 microfarad, and it is your 5 microfarad. And all the three are parallel. Parallel, that's it. Okay, after that, there is one more capacitor is there, which is in series connection. That is your 10 microfarad. This is your 10 microfarad, which is in series connection here. So it is your 10 microfarad. Now what you have to do, you have to find the C equivalent for the parallel, and after that you have to do the series connection for the 10 microfarad. So try to find the C equivalent total for the circuit. Give me the total value for the circuit. Please do it. So this type of questions will be there for your NEET. Okay. Try. Give me the value for C equivalent. Anyone? What is the equivalent capacitance? 10. Others? 10 கிடையாதுமா answer. 10 கிடையாது ஸ்ரீதேவி. கொஞ்சம் check பண்ணிக்கோங்க. What is the answer, ma? Others? Can you please tell me? Yes, ma, Tarani. 5. It is 5 microfarad. Correct. Okay, I'll do it. Please check பண்ணிக்கோங்க. So here if you see that all three are in parallel connection. So for parallel connection, what is the formula? So it is C1 plus C2 plus C3. So which is equal to 2 plus 3 plus 5, which is equal to 10 microfarad. Okay, it is 10 microfarad. And this 10 microfarad and other 10 microfarad both are in series connection. Both are in series connection. So for both are in series connection, what is the formula? So it is 1 by C equivalent is equal to, it is a 1 by C, that is your 1 by 10 plus 1 by 10. So which is equal to 2 by 10. So it is 1 by 5. So when you reverse it, so C equivalent is equal to your 5 microfarad. C equivalent is equal to 5 microfarad. So this is your answer. Please take it. Or right now. Okay. So let's please take this one. Or ma? Yes, ma. Okay, good. So let's see one more. Similar to that, similar to this one only, 66. Please take this question 67. And continuous இது வந்து these type of questions. So 66 to 67 வந்து we can expect in resistors also. So this type of question is very much important. Ma. Okay, miss பண்ணாதீங்க. So example 67. It's easy only. அந்த அளவுக்கு tough எதுவுமே. Example 67. Please take the question. I'll let you know. So how to solve it. 67. Take it. Okay, ma. So let's see the question. So here, if you see that the question, I'll read the question. 5 capacitors of capacitance 10 microfarad, all are of 10 microfarad, each are connected with each other as shown in figure 2.74. Calculate the total capacitance between the points A and C. Total capacitance between the points A and C. Okay, remember, so this question, this type of question, okay, it is related to a circuit called Wheatstone bridge. So it is related to a circuit called Wheatstone bridge. So Wheatstone bridge you will study in your next chapter, that is your current electricity. Okay, so Wheatstone bridge. So Wheatstone bridge. So this Wheatstone bridge used to identify the unknown capacitance or unknown resistors. Okay, and it works on the principle of balancing circuit. Works on the principle of balancing circuit. Okay, anyway, we'll discuss in detail about this circuit and things that is your wisdom teacher and all in next later classes and all. Okay, let's just complete this one. So here in this one, so there are 5 capacitors are there. I'll redraw the circuit here. 5 capacitors are there. So this is your A point. So capacitor C1, so capacitor C3, capacitor C5, and this is your B C point. And in between, so from this point to the C3 point, there is a capacitor. So this capacitor is C4. And here also from this point, that is your B point, from B point to end, you'll take it as capacitor C2. So now if you see that, so first of all, we'll see what is series and what is parallel connection. So parallel series connection based on that we can able to solve it. Earlier on, we don't have C4 and we don't have C3 and all. That is your C2. So C3, C2 kadiyadu. So easy on the we can say parallel connections. So we have solved it. But if instead of the parallel connections, instead of we are placing a capacitors, how to do and what are the conditions we'll see. As usual, I'll apply some charges passing through it. So there are different charges are passing through all the capacitors. So we can say all are parallel. We can say all are parallel, but we cannot be able to identify from where we have to start. Okay, because equally it was divided. So let's see, C4 is equally divided to C1 and C3. C2 is equally divided to C3 and C5. So we don't know how to solve it. Okay, so to do that, to solve this one, so we have to redraw the circuit in Wheatstone bridge format. Okay, so the format is like this. So for that, what I'll do, I'll take the points like this. So here it is your A point. Okay, and at the A point, there are 2 capacitors are dividing. So just see this, just try to understand. At the A point, there are 2 capacitors are dividing like this, parallel. So I'll take this one as a C4. Okay, this is your C4 and this is your C1. Two capacitors are splitting like this, C4 and C1. Okay, and if you see that, I'll give some names. So this point I'll give it as B point, and this point I'll give it as D point. Now same thing at the C point, I'll draw 2 more capacitors. So B to the C point, 1 more capacitor, and D to the C point, 1 more capacitor. So this is your it is your C4, it is your C2, okay, and it is your C5. Okay, let's just see that. So D K below there will be having a capacitor. This is your capacitor. I'll redraw this circuit like this, like a rhombus shape. This is your Wheatstone bridge. So you can check it. So the B point C1, C4 on the taniya poitrukku from the A point, and same thing for C5, C2. It was splitting like parallel. And in between BD common BD is a common point here. Okay, so the circuit here, the capacitor is C3. Okay, Wheatstone bridge எப்படி work ஆகும்னா, so it depends upon the balancing and சொல்லியிருக்கேன். When the circuit is balanced, okay, when the circuit is balanced, okay, balanced condition என்னன்னா, so here if you see the capacitors, direct நான் formula கொடுத்துடுறேன் to identify the balancing இந்த மாதிரி circuitsக்கு. So C4 by C2 is equal to C1 by C5. So instead of taking the values, now in the Mari on the numbers கொடுத்துட்டேனா, so C4 by C2 is equal to C1 by C5. C4 by C2. So what are the capacitor values here? All capacitors are of 10 microfarad. So it is a 10 by 10 is equal to 10 by 10. When the values are same, we can say the circuit is under balance. When the circuit is under balance, there is no charges passing through C3. There is no charger passing through C3. So no charges are passing through C3. When no charges are passing through C3, what will happen? So C3 will be 0. C3 will be 0 here. Remember it, when no charges are passing through C3 will be 0. So that moment we can say that, so C4 and C2 are in series connection and C1 and C5 are in series connection. Okay, when C4 and C2 are in series connection, what is the capacitance formula here? So it is your series 1 by C equivalent is equal to 1 by 10 plus 1 by 10. So it is nothing but your 2 by 10, it is nothing but your 1 by 5, which is equal to 5 microfarad. That is your C equivalent for the top portion. I'll redraw the circuit like this. So this is your 5 microfarad. And same thing for the bottom also. Same 10 microfarad. So again the same value will be there, that is your 5 microfarad here. Okay, so these two are connected in parallel now. So it is your A point and it is your B point. So for parallel, the C equivalent is equal to your 10 microfarad. Remember it, it is related to your Wheatstone bridge. For this Wheatstone bridge, this type of circuits, try to consider the balancing circuit. Okay, other formula on the C4 by C2 is equal to C1 by C5. Or you can remember like this. Now I'll give some numberings here, names here. So it is P, Q, R, S. So you can say that P by Q is equal to R by S. So if you check it whether these are equal, then the circuit is under balance. So when the circuit is under balance, center part lo whatever the part is there, whatever the capacity is, a capacitor, resistor, galvanometer, it will be zero. So that moment we can able to solve it. So this is your condition for Wheatstone bridge. So there are derivations and we will discuss in next chapter. Okay, please take this one. So the value for this capacitor is 10 microfarad. Please take this. Or okay, good. So let's see one more. Take the question 70. Question 70. Okay, so let's see the question. So in this question, so example 70, so if C1, C2 and C3, that is your 20 microfarad, 30 microfarad and 50 microfarad, and the insulating plate of C1 be at a potential of 90 volts. So it is at a potential of 90 volts here. So the point of 90 volts. Okay, one plate of the C3 being earthed. Okay, one plate of the C3 is being earthed. Okay, what is the potential difference between the plates of C2? So we are going to find the potential difference at the plates of C2. So we are going to find the voltage for it. Three capacitors being connected in series. So C1, C2, C3 are connected in series here. So what we need to find? We need to find the potential at C2. So it is easy only. If you see that, so same circuit, I'll redraw like this. So three capacitors, 1, 2, and 3. Okay, so it is earthed. That means, so I can draw like this. One is your positive and one is your negative. So the negative terminal for the C3, so it is connected to grounded. So grounded as the potential difference on the 0 volts. Remember, the grounding part, the potential difference is equal to 0 at the C3 part. And at the C1, the potential is nothing but your 90 volts. Okay, so it is C1 and C2 potential we need to find C2. Okay, so for that what I'll do, I'll take an equivalent capacitance for this case. So let's see the equivalent capacitance for this. So if you see that all three capacitors are in series connection. So series connection now it is a 1 by C equivalent is equal to, it is 1 by C1 plus 1 by C2 plus 1 by C3. So which is equal to 1 by C1 is nothing but C1 value is 1 by 20 plus 1 by 30 plus 1 by 15. Okay, so just take the LCM. When you do the LCM, the value will be around, it is a 3 by 20. Okay, so when you reverse it, C equivalent is equal to, it is a 20 divided by 3 microfarad. This is your C equivalent. Now we got the C equivalent. Okay, what we need to find? We need to find the charges passing through the circuit. So charge and the same charge than in a series connection. So the value will be Q is equal to CV. Q is equal to CV. So in the starting point at this point it is 90 volts and direct. So we are going to apply this 90 volts to these three capacitors. Q is equal to CV. C is 20 by 3 into your voltage. Voltage is nothing but your 90 volts. It is 90. Okay, so it is 3 times. Okay, so the value will be around 600 micro coulomb. Remember, this is your charge. Now we got the charge. So now we need to find the potential across your C2. Potential across C2. I'll take the relation as V2. So V2, in charges, same charges flow at which is equal to Q. So we know that Q is equal to CV. Q is equal to CV. If you want to find B, B is equal to Q by C relation. So charges the same. Okay, capacitance value on the change outcome. So Q divided by C2. This is your relation to find V2. So from this, V2 is equal to, it is Q. Q is your 600 into 10 power minus 6 divided by the capacitor value. Capacitor value is nothing but your 30 micro. 30 into 10 power minus 6. Micro will get cancelled. So it is a 0 times. It is a 3 times. It is 20. So voltage across your capacitor C2 is equal to 20 volts. Please take this one. Okay. Have you taken this now? I don't know what happened to this. Right now, okay, good. So, I'm just getting the book. Yeah, okay. Others, have you taken this? Yeah, okay, good. Okay, fine. So you'll see next one. Just displaying the book. Okay, please take this one now. 71. 71. Take the question 71. Okay, so in this question, so I'll mask it. Okay, right. So in this question, so there are three capacitors are there, C1, C2 and C3 in this circuit. If the point C is earth, so there is a point C is earth. Okay, where when there is a earth, now remember voltage V is equal to 0 at that point. And point A is given a potential of 1200 volts. It is your plus positive. If the charge on each capacitor and the potential difference at point B is what we need to find, we need to find the charge at the B point and we need to find the potential at the B point. So let's just see. So for this circuit, first of all, we'll try to find the equivalent capacitors. Try to find the equivalent capacitors. So what I'll do, I'll redraw the circuit. So we don't want the voltages, we want the equivalent capacitors. So this is your capacitor, this is your capacitor. If you see that, so this capacitor is equal to your 3 microfarad, it is your C1. So this is your C2 and it is your C3. It is your 2 microfarad. And here it is your 4 microfarad. Okay, now, so we see that this C3 and C2, C3 and C2 and C3 are in parallel connection. Parallel connection. So parallel connection formula is it is C1 plus C2. Okay, sorry, C3 and C2. Okay, now I'll add it. When you're adding it, the value will be around it is 4, 6. So it is your 6 microfarad. It is your 6 microfarad. Now, so after that, we are going to find the equivalent for the series connection. So it is a 3 and 3, so which is your series connection. So the formula is 1 by C equivalent is equal to 1 by C1 plus 1 by C2. So which is equal to 1 by 3 plus 1 by 6. So which is equal to, if you solve it, you will get around 2 microfarad. Okay, so this is your C equivalent. So now reverse point, so the C equivalent is 2 microfarad. Okay, now we got the C equivalent here. Now what we need to find, we need to find the charge passing through the circuit. So charge, I'll take the charge Q is equal to CV. Remember, in the charge, the same charge flow till this point. Okay, so whatever the charge is there at the A point, the same charge will be there at the B point. So question another, we need to find the charge at the B point. That's it. Q is equal to CV. So charge is your 2 micro, that is your 10 power minus 6 into your voltage. Voltage is nothing but your 1200. Okay, so what we need to find, we need to find your charge. So it is nothing but your 2400 microcoulomb, or I can write this relation as 2.4 into 10 power minus 3 coulomb. 10 power minus 3 is nothing but your millicoulomb. So 2.4 millicoulomb. This is your charge. Now what we need to find, we need to find the potential difference between at the point B. To find the potential difference, so உங்களுக்கு already தெரியும் potential difference is nothing but the difference between the 2 points, the VA minus VB, and so we have seen the relations. Now, so the same thing we are going to see here. So potential difference between the 2 points. So the relations are like this. So at the A to B, so I'm going to find the potential difference between these 2 points. So VA minus VB. So the relation is VA minus VB. The potential difference between the 2 points is equal to, as C1 than irukku charge, so it is equal to Q by C1, where we know that Q is equal to CV, so V is equal to Q by C. So here, which is equal to, so Q, we know Q is nothing but your 2.4 into 10 power minus 3 divided by capacity C1 is 3 into 10 power minus 6. Okay, so from this relation we can able to find VA minus VB. VA minus VB, and now it will be around 800 volts. So it is your 800 volts, VA minus VB on the 800, and we know that VA is 1200 volts because of the particular terminal. So VA is equal to 1200 volts. Now from this relation we need to find VB. So VB is equal to, VB is equal to, it is your 1200 minus 800. So which is equal to 1200 minus 800, which is equal to your 400 volts. Okay, so this is your VB ma. Okay, now we got the VB and we got the charge. So this total charge at the B point, and it is your VB. So what we need to find next, we need to find the charge on each capacitor. So we need to find the charge on each capacitor. So after finding VB, we are going to find the charge on each capacitor. To find the charge on each capacitor, we are going to find the potential difference. And now V then I can able to find it. So to find the potential difference, the relation will be, because these two are parallel, same voltage. I'll take the relation as VC minus VB, the difference. VC minus VB. So VC is 0, VB is equal to 400. So the difference is 400 volts. So across these two capacitors, voltage on the 400 volts. And a voltage theorem. So I need to find the charge. For this C2, Q is equal to CV. That is your 4 into 400 microfarad. And same thing here also, Q is equal to CV. That is equal to 2 into 400. So the value for this charge at the C2, so it is will be 4 into 400. I'll take this relation as 1.6 into 10 power minus 3 coulomb. Okay, and here 2 into 400, it will be around, it is 0.8 into 10 power minus 3 coulomb. Okay, so these are your charges. Please take it. So if you have any difficulty, please let me know. The potential difference based on that. Got it, ma? Over? Right, ma. Super. Okay, let's see one more. So next question. So similar to this, Ningale try panla. Please try it. So next question, 73. Let's see. So question number 73, ma. Please take it. capacitors C1, C2, C3 are connected to a battery of 12 volts as shown in figure. Find the potential difference between the points A and B. We're going to find the potential difference between the points A and B. Okay, so let's see for this one. So what I'll do, I'll take this one, I'll mask it. Right. So for this question, for this one, four capacitors C1, C2, C3, C4 are connected to a battery of 12 volts as shown in figure. Find the potential difference between the points A and B. We need to find the points A and B. In the potential difference we need to find. Earlier we are finding in series connection. Upon the opposite level. Okay, let's see that. So first of all, we'll see the potential difference across the capacitors. Potential difference across the capacitors. அது எப்படி இருக்குன்னு பார்க்கலாம். So in the point the voltage is your 12 volts. Okay, remember the voltage is your 12 volts, and in the point it will be approximately it is zero actually. Okay, now the opposite. Let's see that. எப்படி இருக்குன்னு பார்க்கலாம். So we'll see the potentials for the capacitor C1. So what I'll do, the potential difference across capacitor C1, I can take the relation like this. It is nothing but the difference between these two. I'll take it as 12 minus the potential VA, because we don't know what is the potential at VA point. So I'll take it as VA. Okay, it is 12 minus VA. So 12 is nothing but this one. So இது இங்க இருந்தாலும் okay தான், இந்த pointல இருந்தாலும் okay தான். The potential at this point is 12. So 12 minus VA. And same thing for C2. C2 capacitor. So I told you this point is nothing but your zero potential. So I'll take it as VA minus zero. So this point is the potential. It is VA minus zero. It is across C2. And here C3 we'll see. So C3 is nothing but your 12 minus VB. Remember 12 minus VB. It is 12 minus VB. And here the same thing, the potential across C4 will be VB minus 0. So I'll write here itself. So the potential difference across C1 is your 12 minus VA. Okay, and C2 is nothing but your VA minus 0. And C3 is nothing but your 12 minus VB. And C4 is nothing but your VB. So these are the four different capacitors. Now, so let's see that. So as the capacitors C1 and C2 are in series connection, remember C1 and C2 are in series connection. When C1 and C2 are in series connection, we can say the same charge is flowing through it. Remember, the same charge is flowing through C1 and C2. We can say the charge same passing through C1 and C2. Same charge. When it is your same charge, what we can say, so we can take the relation. So that is your Q is equal to CV. I'll take the relation as a Q C1 V1 is equal to C2 V2. Okay, so I'll take the relations as it is a V1 and it is V2, it is a V3, and it will be approx V4. So the relation will be like this. So C1 will be C1, because I'll take the end part here. So V1 will be your 12 minus VA is equal to, so C2 is nothing but your V2 into, so C2 is nothing but your 4, so I'll take directly it is C2, and V2 is nothing but your VA, it is nothing but your VA. So when you're equating the two relations, so let's see that. So it is a C1 is nothing but your 8 microfarad into 12 minus VA is equal to your 4 microfarad into C2. C2 is nothing but 4 and it is your VA. Okay, so microfarad will get cancelled here. So when we solve it, we can able to find VA. So from this relation, VA is equal to 8 volts. VA is equal to 8 volts. Now we got VA here. So after finding VA, now at the bottom part. So let's see for the C3 and C4. For the C3 and C4, same relations. Making charges same here. So for C3 and C4, so the relation I'll take as C3 and C4 having same charges. So the relation I'll take it as Q is equal to C3V3 is equal to C4V4. So C3 is nothing but your 3 micro into V3 is nothing but 12 minus VB into is equal to, it is C4. C4 is equal to 6 micro into V4 is nothing but your VB. So micros will get cancelled here. So from this relation we can able to find VB. So VB is equal to, the relation will be 4 volts. VB is equal to 4 volts. So now we got VA and we got VB. Now we are going to find the difference between the A to B point. Remember, potential difference between A to B point. Between A to B. So the potential difference will be VA minus VB. So VA is equal to 8 volts minus VB is equal to 4 volts. So the value will be 4 volts. So this is your potential difference between the 2 points. Please take this one. Orma, others? Yes, 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 yes. Okay. Yeah, okay, fine. Okay, let's see one more. So இது நீங்களே try பண்ணுங்க. So let's see that. So try to solve the question 12. 1, 2. Solve this one, 12th one. Please check it whether you are getting the value of 0.5 microfarad. இங்க ட்ரை பண்ணணும், அங்க ஆன்சர் இருக்குன்னு சொல்லிட்டு சும்மா இருக்காதீங்க. Okay, so try to solve it. Got the answer? Others, any doubt? Doubt in the solanga, I'll explain it. Please, if anyone having doubt, please let me know. I'll explain it. Okay. So here, if you see that we need to find the equivalent capacitance. That's it between the points A and B. So we see that 1 microfarad and 1 microfarad. These two are in parallel connection, and here 1 micro. These two are in parallel because the two different currents are there here. Okay, so when you solve these two, it will be around, it is a 2 microfarad because parallel connection add pandrom. Here also it is your 2 microfarad and middle it is 1 microfarad. All these three are in series connection. So the value will be 1 by C equivalent is equal to 1 by 2 plus 1 plus 1 by 2. So it is your 2 by 2 plus 1. Okay, so it is 2 by 2. So you can say if you can take the LCM also, it will be around your 0 0.5. That is your 2 and it is your 0 0.5 microfarad. It is your C equivalent. Okay, so please take this one. Okay, good. Others got the answer? So let's see one more. So நீங்களே try பண்ணுங்க இது. Okay, so try this one. 14. Try 14. 1 4. 14th. Okay, got the answer, ma? Check it. See. So here there are three capacitors are there. One, two, three. So C2 and C3 and C4, all three are in series connection, and after that here 4 and 2 are in series connection. So if you solve this one, so the capacitor value will be 1 by 4 plus 1 by 2 plus 1 by 4. So the relation will be it is 2 by 4 plus 1 by 2. So it is 1 by 2 plus 1 by 2. Okay, so you can solve this one like that. Here also it is series connection, so it is 1 by 4 plus 1 by 2. So I'll take it as 2 by 4. So it is a 3 by 4. Okay, so when you reverse it, it is 4 by 3. So again these two are in parallel connection, and parallel connection ரெண்டுமே add பண்றீங்க, and after that you are going to get the series connection for this capacitors. So just take this one, try to do it. Okay, so 14th is your homework, and take this one also in the question. So 14th and this question also. So this question I told you it is like a similar to your Wheatstone bridge. So first of all you have to check whether it is in balanced condition, and after that you have to solve it. So balanced condition when formula under the P by Q is equal to R by S. So here it is P, I'll take this one as P, it is a Q, it is R, and it is S. So in the values you have the ratio pannanga, value same you have to solve, you have to cancel this 10 microfarad capacitor. You cancel pannittu, you have to solve it. Okay, so please take this one as your homework. சந்தியா உங்க வீடியோ ஆன்ல இருக்குமா? கொஞ்சம் மியூட் பண்ணுங்க. ஐ மீன் ஆஃப் பண்ணுங்க. வீடியோ ஆன்ல இருக்கு பாருங்க. Thank you. Okay, take these questions, ma. That's your homework. And I seen உங்க நேம்ஸ் வந்து நான் சேவ் பண்ணி வச்சுக்கிறேன். So those are attended today. So I'll give the username and password. Okay, others எனக்கு தெரியாது. So those are attended today's class. எனக்கு தெரிஞ்சு ஒரு 12 members இருக்கீங்கன்னு நினைக்கிறேன். So I'll give the user ID and password to you people. So நாளைக்கே உங்களுக்கு வந்து user ID password வந்துடும். So you can have your test. Okay, இனிமே எல்லா டெஸ்ட் வந்து it will be online only. Okay, so over. So far any doubts ma? Today's class problems இருக்கு, நிறைய இருக்கு problems. நான் at a time ஒரே கிளாஸ்ல நம்ம எல்லாமே பண்ணிட்டோம்னா it won't be good. So next class we'll complete only two content இருக்கு related to your dielectric. So once we complete that, then the chapter will be over for you. Okay, so the derivations வந்து நம்ம complete பண்ணுவோம். And next class, suppose if possible, we'll start your class 11th topic, and or else we'll start your current electricity topic. Depends there. Okay. So on the next class நம்ம பார்க்கலாம். Suppose if you want, we'll start your class 11 units and measurement வந்து நம்ம start பண்ணலாம். So I know that you people have forgotten those things and all. Okay. So we'll see that. Okay. Right. Any doubts? Please do practice. There are so many sums are there. நான் கொடுத்த questions எல்லாம் வந்து important questions தான், repeated questions தான். Okay, please do practice these things. There are so many stuffs are there still. Okay, any doubts? Any doubts? Okay, ma. Right. So we'll see next class then.